Hello, this is Algebra, section 10-3, radical equations. We're going to learn how to solve radical equations with radical expressions in them. We are also going to learn about extraneous solutions. As always, please have your math journals out to take notes, just like a regular class. Everybody find a seat, and let's begin. From our get ready for the lesson in this section, we are learning that we have an expression, and it looks like this. T is equal to the square root of h over 4. Okay, where t is the time in seconds that it takes an object to fall h feet. Okay, so t is in seconds, and h is in feet. And t equals the square root of h over 4 is a radical equation because there is a radicand in the numerator of this. So this makes this whole thing a radical equation. We're going to do example 1 here, and that's on page 451. I've pasted this in so that you can read it along with me. Doing these kind of problems is difficult with me just reading them out loud. So, two objects are dropped simultaneously. The first object reaches the ground in 2.5 seconds, and the second object reaches the ground 1.5 seconds later. From what heights were the two objects dropped? Okay, so this is where we're going to use our formula here. T is equal to the square root of h over 4. All right. Now, with radical equations, you treat them just as if they were normal expressions in which you have to isolate the variable. Okay. So, in this case, we have two different t's. Okay. We have, let's see, we'll have object 1. Okay. And the t for that was 2.5 seconds. Okay, and then over here, we're going to have object 2, and the t for this was, 2.5 plus 1.5, which is, 4 seconds. So we plug this in. 2.5 is equal to the square root of h, because the h is what we're looking for, over 4. Well, you isolate the term with the variable in it, which we have. Now you solve for the variable. What's being done to the h? Well, right now what's being done to it is that you have the radical sign. Remember PEMDAS? Okay? Radical sign takes precedence over division. That means that we undo what's being done last. Right now, last is divide by 4. So we need to multiply both sides by 4. Okay? So PEMDAS rules even here. Okay, so 4 over 4 is that. I'm going to rewrite this with the variable on the left side. We have the square root of h is equal to 4 times 2.5 is, well, let's hope it's 10. So now we have the square root of h is equal to 10. What we want to find is what h is. How do we get rid of the radical sign? We get rid of the radical sign by squaring both sides of the equation. Okay, now here, squaring it is more or less trivial, but it gets a little more interesting later on. Okay, so we have the square root of h, that quantity squared, is equal to 10 squared. Well, when you square a square root, the square root goes away, and you just have what's underneath it. H is equal to, what's 10 squared? 10 squared is 100. Okay, so that is the height that the first object was dropped. Now, let's go over here and do the same thing for this one. So we end up with 4 is equal to the square root of h over 4. We do the same thing. We multiply both sides by 4. All right, they go away. We end up with 16 is equal to the square root of h. I didn't rewrite it with the square root of h on the left side this time. We square both sides. 16 squared is equal to the square root of h squared. Now I'm going to write with the variable on the left side. So squaring a square root, you get rid of the square root sign, you're left with just h. And 16 squared is 256. So object 1 was dropped from a height of 100 feet, and object 2 was dropped from a height of 256 feet. And here we go. Let's do another example. Let's do example 2. On page 542. And this is going to be an example where your radicand is an expression, not simply a variable like h was. Okay? And it says solve this equation. So we have the square root of x plus 1 plus 7 equals 10. First term, or the first thing that you do in a radical equation, is you isolate the term with a radical. All right, you isolate the radical on one side of the equation. So here's radical x plus 1. We want to get rid of this plus 7 on this side. So we subtract 7 from both sides to move it over, and we're left with the square root of x plus 1 equals, well, 10 minus 7, hopefully, is still 3. Again here, then, how do we get rid of the radical sign? We get rid of it by squaring that term. So we end up having to square the whole thing. And since we square one side, we have to square the other side of the equation to maintain the balance, okay? So when you square a radical sign, whatever's under the radical sign just comes out. Just like that. 3 squared is 9. Therefore, x is equal to 8. Now, let's go back and check this real quick, okay? And you'll see why in the next piece of this. So if x is equal to 8, the square root of x plus 1 plus 7 is equal to 10. Well, we drop in 8 for the x, and we get the square root of 8 plus 1 plus 7 is equal to 10. Well, the square root of 8 plus 1 is the square root of 9 plus 7 is equal to 10. Now the square root of 9, because these are all numbers now, they're all positive. So therefore you only need to deal with the positive root of 9, which is 3, plus 7 is equal to 10. Therefore 10 is equal to 10. And your solution checks. Okay, that's important for what we're going to do next. So extraneous solutions. What is an extraneous solution? It's a solution that's derived from an equation that is not a solution of the original equation. And what does that mean? Well, remember that when we're solving radical equations, we have to square both sides of the equation to get rid of the radical sign. Now that means that the equation we're working with afterwards is not the same as the original. It's equivalent, but it's not the same. Therefore, that not the same part, we've introduced a second solution, a second root. Now, is this true in all cases? No, but it is true in some, a fair amount actually. And you'll learn and see here what to do about them. Let's do example 3. That's going to be on page 542. All right, and it says to solve this guy. The square root of x plus 2 equals x minus 4. Haha, you say. Exactly. Okay, so that's the original equation. Well, what are we supposed to do about this? We have to square both sides. We can't move the x or the 4 over to this side with the radical sign because we need the radical expression all by itself. So we have to square things as they are. So we have the square root of x plus 2, quantity squared, is equal to, well, now that we have this, we have to square this as a term. Just like that. Huh, how about that? When we square a radical sign, whatever's under the radical sign just comes out. Okay? X plus 2. And that's going to be equal to, you guys should be able to do this in your head now, x squared minus 8x plus 16. Haha. Okay, now what we're going to do is move the x plus 2, and we're going to move it over here, right? So let's subtract an x, and we'll subtract an x from here, and we're going to subtract a 2, and we're going to subtract the 2 from there. And so what this means is that this whole side is going to be 0 equals x squared minus 9x plus 14. Okay? Yes, and there are people who have already factored this already, so we're going to move that over to this side. Equals 0. So we have an x and an x, and since we have a negative in the b part, both of these are going to be negative, right? Because c isn't negative, therefore they both have to be negative. And what multiplied together gives you 14 and added together gives you 9? 7 and 2. Then we have to use our zero product property to determine which of these, or what x's make this 0. So we have x minus 7 equals 0. X is equal to 7. And we have x minus 2 is equal to 0. X is equal to 2. Which one of those is the answer? Well, we're going to find out. Let's come up here and we're going to do our check. Okay, so we're going to do x is equal to 7 first. So we're going to say the square root of 7 plus 2 is equal to 7 minus 4. The square root of 7 plus 2 would be the square root of 9 is equal to 7 minus 4 is 3. So therefore we have 3 is equal to 3. That checks. That's a valid identity. Now remember, since we're dealing with all numbers, the numbers are positive, therefore we only need to worry about the positive root. Now we're going to check x equal 2. So we have the square root, x plus 2, so we have 2 plus 2 is equal to, and x is 2 again here, 2 minus 4. So we have the square root of 4 is equal to 2 minus 4. 2 minus 4 is negative 2. The square root of 4 is what? It's 2. Now this is where I don't want you getting confused. These are all numbers. There's no negative sign out in front of the radical here. Nothing. It's a positive root, so we want positive 2. So in this case, positive 2 does not equal negative 2, and this is the extraneous solution. So our real answer is x equals 7. That's it for this video. If you have any comments or questions, please email them to me, and thank you for watching.